Okay, so for this new tube furnace design, what you need to do is take some of this DAP, heat resistant mortar, and a ceramic tube. This one is I believe an inch and a quarter wide, and this nichrome wire. You need 3 feet of this nichrome wire and wrap it around the ceramic. It's alumina oxide, and then after wrapping it, you put the high heat mortar on it with this paintbrush, and that's what you do with that. And then you take the glass borosilicate glass tube and you wrap copper tape around it, so that when you put it on here, it's a tight fit. And then after that, you're going to wrap the whole thing with fiberglass insulation, and then heat exhaust wrap, and then it should work. I'll show that later. Just wait a little bit. See, it's very tight. Just wait a second. Okay, so it's very tight. You want it tight so you don't have any air in between, so the heat can conduct from the wire through the ceramic to the glass. That's what the copper is for, the copper tape. Okay, and from the previous video, you know how I'll wrap this, but I'm gonna wrap it again and do that. But I'll splice it with this video. So for right now, you're gonna see a time skip. Okay, so now to put on the insulation. Okay, you see about this long. I need to get a knife. I forgot to grab the knife. Ta-da, knife. Now, I need the other wrap. Okay, yeah, here's another lesson, kids. Be much more organized than I am. Have all your stuff at the beginning, so you don't end up having to look for it, like I'm having to. Okay, here it is. And then after you wrap this around there, you gotta use these metal zip ties to like hold it. And wow, that's not good. Here it is. Just gonna put that there. Gotta make sure it's good and tight, so you want to probably get another pair of hands to wrap it while you hold this down tight. Which I'm going to go do now. So you're going to see a time skip here. Okay, so I got some help wrapping it. Now the insulation's there. Now it's just time to see if it works, finally. This is a thermocouple right here. Just gotta tell me the temperature. wire's bending from the weight. Gotta get a stone block. just go watch the thermocouple and see what happens. Okay, so thermocouple says it's 66, but it's growing and it's not directly in the middle, so just gotta wait a little while and see if this works. So I guess you'll get a time skip, but here, look. Okay, so I'm just gonna wait, and I'm not gonna record this part until it starts reaching the temperature I want. So, and if this modified version of the tube furnace works better, I'll upload it in the video. Okay, that's it. Okay, so it's 600 degrees Celsius right now with the thermocouple right there. So it's getting there. Earlier it caught fire. We don't know what part caught fire.
200,
yeah. Yeah, it caught fire around like 200. So, but it doesn't seem to be on fire now. But there's smoke coming out. So we think it's this white insulation here, but we don't know. We're gonna test the insulation later with a torch and see what burns. But yeah, it seems to be working. Oh, except this thermocouple keeps turning off. Gotta change the settings. Okay, 630. And the tube furnace still seems, the glass doesn't seem to have broken, so okay, I'll record again after we do our tests and see, and try to see what's wrong. But it seems to be working but you have to deal with fire, so still need to improve it, and don't breathe the smoke. So it seems that it wasn't the white insulation, it was the black mortar, whatever that was making it malleable and gooey, like what evaporated and went through a chemical change to where it become from black to gray, as you can see here. And here's the copper tape that was on the tube. I've scrubbed off most of the black stuff, but you can still see there's a lot of it in here. And so it stopped smoking after a while after it did the chemical change, so there was no more fire and there was no more smoke. And the glass seems to be fine, but the problem is I went too far on the current and I burned out the wire, so I'm gonna have to put on new wire and then do this again. I'll do that tomorrow. But it seems that this design works as long as you don't go too high on the current, but it reaches 800, 900 degrees Celsius, so that works. Just you have to deal with smoke at the beginning from the mortar. So yeah, 3 feet of nichrome wire wrapped around this ceramic tube, then the borosilicate tube in between there, and you wrap that all with the insulation, and yeah, that's it. Okay, so here's a simple solution to the whole vapor problem. You just take a propane torch or whatever other like little torch you have, and you just run it across your mortar insulation. And of course do this outside because of the fumes, or if you have a fume hood, you could do it there. And of course have your gloves and safety equipment, but yeah, you just run that across here like I've done and try to distribute the heat evenly. But speaking about that, it won't get all of it. Like, it just gets the top layer. Like, underneath it, it's still black underneath the gray stuff, so you'll probably get like about half of it and just the top part. So when I plug it in later, I'll probably still get some fumes, but it'll be much less than before. I guess it technically what you could do is do a little bit, wait for it to cure, and then use your torch, and then put another layer on and do that again. But that would and keep doing that layer by layer, but that would take too much time because you gotta wait like 12 hours for this stuff to dry before you put the torch on it. So I think this is just the best solution. Put a torch over, get most of it, then plug it in and it'll do the rest. And make sure give yourself good circulation. Don't breathe into fumes. Okay, well, I'm just gonna go ask someone to help me wrap it with this stuff again, and then I'll plug it back in and use it. Okay, that's it. Okay, so here it is after fixing it up. Let me just get this. The voltage is like 19 volts and the amps is 24. So it's survived more than one test. This design seems to work. So yeah, you have the borosilicate tube, then you put copper tape around that, and then put a ceramic tube on top of that. Then you put the nichrome wire, and then you put the mortar. And if you want, you after the mortar dries, you torch the mortar, and then after, oh, it was getting to like 700. Then after torching the mortar, if you want, or you don't have to, then you wrap it with this super wool insulation or ceramic wool insulation, and then you put the heat exhaust wrap on top of that. And just, I used metal zip ties here and just connect it to the power supply and run it and feed it oxygen or not. It depends on whatever you're putting in the tube furnace. But yeah, this design seems to work. Oh, and again, the smoking's just from the mortar. Even though I torched this one, that only got some of it. So it's still smoking from the mortar, but after about an hour, it'll stop doing that. Once all the mortars turn, gray and brittle. It's gone through the whole chemical change. So also, like, vent, don't breathe in the fumes. Well, this seems to have worked, so I'll upload it that this is the modified tube furnace, and I think this is the final version. Okay, that's it. Okay, so as you can see, this tube furnace is different because I burned out the wire again, going to like 27 amps and like 22 volts. So we're not going there, but here at 20.1 volts and 25 amps, according to this thermocouple that I put in there, it is 918.1 degrees Celsius. So, and this is with 3 feet of nichrome wire. And here you can see the current and voltage again. So yeah, we are able to get to the right temperature. Except the thermocouple, as you can see, leave it in there too long and it burns. Oh great, now the wire came off. Gonna have to put that back on again. But yeah, the insulation just burns if you leave it there too long. Like up here, there was all insulation, but that's all gone now. So yeah, thermocouple is only meant to do like 700, so we're pushing it. Yeah, so gonna have to fix that thermocouple. But this shows that it's able to get to a high enough temperature. Also, I don't know what's wrong with this camera, or maybe my eyes are just wrong, but like looking at the glowing wires, they're a lot brighter through the looking from the camera than from what I look at them. Like how I look at them, they're like just like a light yellow, kind of like a sunset almost. But here, they're like bright yellow, like, yeah. So to me, it's like the color of a sunset. While on the camera, from what I can see on the screen, it looks like the sun is staring directly at the sun at like right at its highest point in the sky. Yeah, it's very bright. So I don't know if the camera is wrong or if my eyes are wrong. Maybe the camera's picking up things I just don't see. But then, if it was, then why would I be able to see it through the camera? Because I'm using eyes to both look through the camera and at the thing. So that wouldn't really make sense. Is it like picking up something and then converting it to something I can see? Like, that... I don't... This isn't like an infrared camera or anything. This is just a standard Galaxy... I think it's a Galaxy Note 10 camera, Note 9, something like that. So, yeah, just letting you know, just this camera I don't think is accurate. Okay, but this is kind of just showing that it works, and so I don't suggest going above this. Because before I was running it at like 26 amps and 22 volts, and it worked for a while, but after about an hour it broke. Well, this has been going on for like more than 2 hours, and it's doing fine. And it gets to the temperature you need of 920 degrees Celsius. So, well, if you want to trust the thermocouple, which again kept getting burned, and now I gotta repair. But I also have the infrared thermometer, which is kind of hard. Like, you gotta put it here and like try to center it right, but you can get a same measurement on that. But it takes a while to like position it right and make sure it's getting the infrared heat radiation from the right source. So yeah, it takes a while to get that one. That's why I was using the thermocouple, because like if I pointed slightly wrong, it may be like say 200, or if I get a little better but not quite right, it may say like 600 degrees Celsius. It takes a while of going around to find the correct temperature, and if you don't know if it's that temperature, you may take one of the ones that are wrong and think that's correct. That's kind of a problem. Okay, well, that's it for now. I'll just show this all again, like when I take it out and crush it and do this a couple more times. Oh, but I also started to run kind of low on oxygen. Like, by the time I do this batch, it should be like to here. So I may need to get another oxygen tank. This is probably like 80 bucks, 85 bucks, something like that. Well, yeah, it's weird. You go to the oxygen supply store and you've already bought the tank, and you may want to get refilled. Sometimes they'll refill it, but other times they'll just take the empty tank from you and give you another tank that's like the same volume and same size and everything, and filled with oxygen. And then you take that, and then they'll keep your tank and then refill it for themselves, but you'll only be charged for the oxygen because the tanks are equipped. Yeah, so it depends on who you're buying it from and what they want to do. But I mean, I don't care. It's the same volumes and everything, same same safety, same materials. So why do you care? You know, marginal utility and all that stuff of economy. It doesn't really matter to me if you're replacing it with the same thing. It's fungibility. So who cares? Same practical purpose. But just imagine someone like being really like this, bonded with their tank. Like, this is my tank. I want this tank. You have to refill it. Like, that'd be funny. Some people really do get emotionally involved with their equipment. Like, even if you replace it with basically in all practical terms the same thing, they want that tank because of, I don't know, they'll usually justify it with some kind of minute like differences that don't really they're just kind of arbitrary. They don't really affect its utility, how useful it is. They just like it because, yeah, I like that paint job, or I like that that writing on it, or whatever. I mean, I like this valve because I like how it turns a little in my hand, or the grooves in my hand. Like, some people get picky and they have equipment for a while and they get emotionally invested. So don't do that. It's foolishness. Okay, yeah, they become romantic. Yeah, they romanticize their tools. Yeah. Well, I'm rambling now. So I'm just gonna cut this off, and then you'll see the time skip after I pull this out and start grinding it again put in again, and then do that like 2 more times, and then need to get some liquid nitrogen and test the superconductivity, and then after that we'll make the next video of making superconducting circuits and then optical circuits and putting them together, and maybe some other videos in between. I don't have a exact plan yet, but it's coming together. Okay, that's it.